Hi, Math 111 students. Thought I'd just make a quick video to give you a little bit more direction on how to do this week 6 written activity. So we're going to model the first, I think it's like year and a half of the coronavirus data from coronavirus cases in the United States. The data starts in January 22nd, 2020, and I can't remember exactly how long it goes, like 600 days or something. All right, so there's a website that it came from. I think that they are no longer updating the website, and that isn't super important. The important part to do is to go to Desmos and look at the data. So we're going to follow this link to complete the assignment. We're going to open up Desmos, and then what I'm going to do is I'm going to have my screen split into two, hopefully so I can figure out how to do this. And that's what I want here. And then, this is annoying. I don't know why that's doing that. Okay. And what we're going to do now is we're first going to do a linear regression in Desmos. So that's what the directions tells us to do. Let's actually give us a little more Desmos, a little bit less directions here. Here we go. All right, so it says to do a linear regression using this command. So here's my data in Desmos, and you can see that it's kind of increasing, whatever. And when you want to go do a command in Desmos, you actually go to this box number 2, and you literally type exactly what I typed there. So Y, and then if you go shift underscore, it drops you down. Like shift the button right to the right of 0, and then 1, and then you right arrow over to get out of the subscript, and then you do a tilde, mx underscore 1 plus b. I don't want to show you my answers because I want you to do this yourself. Look, they're covered up. Isn't that handy? But you can see that it comes up with an equation. Here it is right here in red. You can see that's your linear model. All right, so what I want you to do is write the equation here as the equation. So you're going to write y equals, and whatever you put it, whatever it tells you m was, x plus whatever it tells you b is. If something's in scientific notation, which hint it is, go ahead and convert it to standard form. Then you need to interpret the context of the slope. Remember, that's rate of change of the data. So that's going to be, what is the slope telling us? Rate of change, change in output over change in input, that sort of thing. You should have units on that, so something per something else for the units. And what does it mean, what does M tell us about how the COVID cases were changing? The next thing you're going to do is do an exponential regression. So exactly the same kind of idea, except for this time you're going to use a different equation. We're not doing linear. We're going to go y underscore 1 out of the subscript tilde. That tells you to do a regression a times b to the x1. And you have to have the x1 and the y1 there so it knows that you're referring to this data in this list. And then there's my exponential regression. You're going to convert all scientific notation to standard form and write an equation y equals something for a times whatever the number is for b to the x. Remember how b acts, the parameter b, what does it tell you in an exponential equation? And how does it tell you about how COVID changes or cases are changing per day? So remember, this is how exponential changes in part 2. Part 1 was about how linear things change. Then the last thing you're going to do is you're going to make a prediction using the linear and the exponential. You need to figure out how many cases there would be after 564 days. So plug in x for 564 in your linear equation that you did right here. Plug in 564 into your exponential equation that you did right here, and that could come out with a prediction, right? Then you need to give some mathematical evidence, writing a complete sentence about why you think which model is best, right? There could be more than one correct answer, but it needs to be mathematical and about the model. You could talk about the R-squared value and what that tells you. You could talk about the y-intercept values and what those tell you. Lots of different ways to answer this question, but I do want incomplete sentences, and you must support your choice with mathematical evidence. If you say something like linear prediction is best, period, that's not going to get you any points. If you get stuck, here's a couple links about how to use Desmos. And if you want a little bit of extra credit, find a model that isn't linear or exponential. There's a lot of other functions that you guys know about. Give it a whirl. Doing regression in Desmos is super easy. You just put in the format of the model that you want. If you wanted quadratic ax squared plus bx plus c or something else, right? And then you must explicitly tell me the new model and why you think it's